Hello everyone, good day. Welcome to VSPARKZ. Today we are going to see what are Kubernetes deployments, its concepts, and we are going to see a demo on the same as well. If you like this video, please subscribe to VSPARKZ channel and click the bell icon for the latest updates. This is the agenda of this video. We are going to discuss on these topics in this video. Before starting, I assume that you already know what do you mean by containers, pods, and replica sets in Kubernetes. If you don't know the same, please refer to the previous videos. Let us start from the scratch. Let us first understand how the application deployments are made in a production grade environment, and then we will correlate the same with the Kubernetes deployments. Normally, in a production environment for high availability and load balancing, you deploy your application across multiple machines. Formally, this deployment is called as a rollout. Let's say this rollout version is tagged as V1. After some days, you will develop some new additional features and bug fixes for the same application, and then you will release the same in the next rollout. That is version number 2. This is formally termed as upgrade. That is, you are upgrading your application from one version to the next version. What will you do at the time of your upgrade? You should not wipe off completely the older version and deploy the newer one. If you do like this, your application will have a downtime for upgradation in the production environment. In order to avoid downtime, we will do a type of upgrade called rolling upgrade, where you will deploy the higher version in only one machine. If it is okay, then only we will remove the older instance of that application. This process repeats for all the instances of your application. Now, let us say if you have a bug in version number 2, that is this version. For the betterment, we should roll back the application to the recent working version, which is V1 in our case. This is called as rollback. This will wipe off version 2 and revert back to version number 1. We can also pause our rollouts for time being, just in case if you want to apply multiple fixes all together in a single rollout. Once you have all the fixes, you can resume the rollout to trigger the deployment in a single shot. By now, you should be clear on how application deployments and upgrades are made in a production environment. Now, what is Kubernetes deployment? Kubernetes deployment is a higher level Kubernetes object that actually manages replica sets. These replica sets actually manages the pods or the replicas, and in turn, every pod runs your application. Similar like your application deployment features, which we have seen in the last slide, Kubernetes deployment also lets you to roll out deployments, upgrade pods and replica sets, rollbacks to the previous deployment versions, pass or continue your deployments, and many more. So these capabilities of Kubernetes deployment lets you to run your containerized workloads in the production grade environments as well. Now you would have known what is a Kubernetes deployment. Apart from these features that we have seen so far, Kubernetes deployment also supports other useful features as well. To name some, scaling your deployments. You can scale up or scale down your replicas seamlessly. you can very well track the history of changes that you did for the particular deployment. We can also control your rollout strategies. For example, we can set the deployment method as rolling upgrade or clean sweep deployment method. We can apply multiple fixes or updates to the Kubernetes deployment at the same time. Now, how will you create a deployment? Obviously, you can use kubectl commands to create a deployment, just like this. But the best practice is to use Kubernetes manifest file to create a deployment because it gives options to tweak the parameters of the deployment to a great extent, which you cannot do in a single kubectl commands. You can very well simulate to create the manifest file using the kubectl command, just like this. Once you execute the second command, it will create a deployment YAML manifest file, and then you have to edit that file parameters as like your wish so as to create a deployment. Now let us understand the deployment manifest YAML a bit more in detail. A deployment definition has four important top level fields, that is API version, kind, metadata, and spec. For deployment, the API version should be apps/v1 and the kind should be deployment with letter D in uppercase. The metadata field holds the name and labels for the deployment itself. Under spec, you have three important fields, that is replicas, selector, and template. As per this definition, the number of replicas is 3. Next, under the template section, we need to mention the pod definition. This pod definition tells us that it will create a single container pod with Nginx image. In the selector field, you need to mention the pod labels in order for the replica set to identify the correct pods for its management within the cluster. In our case, the pod label and the selector label matches properly, which is tier::web. If this is not matching, it may lead to erratic behaviors. Now, let us connect this YAML with the deployment architecture. Towards your right, you can see the deployment named web server and with the label env::dev. And here you can see the connections. This deployment has a replica set with 3 replicas and the selector. And here you can see the connections. This replica set has 3 replicas and each replica contains pods with its relevant template definitions. And here you can see the connections. Now we will see a demo on how to create a deployment rollout, how to scale a deployment, how to upgrade a deployment, how to roll back, and how to pass a deployment in this demo. Step number 1, access the Kubernetes cluster using the kubectl command line utility and check if the Kubernetes cluster is up and running properly. Just to save the time, I have consolidated all the commands in a notepad and the same is available in the video description. This is our master node where I have connected to the Kubernetes cluster using the command line. Cluster info command gives the details of your cluster. Similarly, try to check the nodes and the pods. Our cluster is running with 1 master node and 2 worker nodes. Now check if all the control plane components are running in the kube system namespace. Yes, all the components are running. Now it's step number 2, create the deployment manifest using the kubectl commands. So this command with the dry run option will not create a real deployment, rather it creates only the deployment manifest or the YAML file. Now try to inspect the YAML definition file, which is frontend.yaml. Here you can see all the details of your deployment. Step number 3, deploy the manifest file which we have created in the last step. Once you deploy, it will create a new deployment rollout revision number 1. This deployment is going to have only one replica. Just apply the YAML definition file. Yeah, it is applied now. Check the rollout history and the status of the current rollout. This rollout history command will show you the deployment revisions. Now, the status is clearly indicating that the replicas are getting created at the back for the deployment. We can check the replicas or the parts in another tab. Yep, you can see one part which belongs to that front-end deployment is running now. Step number 4, scale up the deployment replicas to 2. Either you can directly modify the deployment to make these changes, or as a best practice, you can modify the manifest file and apply it in the cluster. For now, we will follow the best practice. Just open the frontend.yml file and edit the changes accordingly. Now I have changed the replicas to 2. Apply this file again. Once you apply, replicas will be spun up, but it will not trigger a new rollout since it is just increasing the replicas and no changes in the current pod template configurations. Here you can see the replica count is increased to 2, which means we'll be having 2 pods. Step number 5, update the image to another version and inspect the deployment. Let's say you update it from 1.20.0 to 1.20.1. Now this will trigger a new rollout version, that is revision number 2. For this step also, we will follow the best practice of modifying the manifest file. Before updating the changes, we will check the rollout history one more time. We can see only one revision is present here. Now go ahead and change the manifest file. That is, we are going to update the image to 1.20.1. Now apply the modified manifest, which will trigger a new rollout revision number 2. By default, the rollout strategy is rolling upgrade. I believe you remember the concept of rolling upgrade during our theory session. Here you can see it is doing the rolling upgrade only, which will update your application seamlessly without any downtime. This means it will create the new pods first with the updated template, and then only it will terminate the old pods. Now all the pods are refreshed. Now check the image version in the pod and it should be 1.20.1. Yeah, you can see the image version is 1.20.1. Step number 6, roll back to a previous revision. Assume that you have a bug in image 1.20.1. You should revert back the application to the previous revisions. Once you execute undo rollout command, Kubernetes will check for the last working rollout revision. It will then take the template and it will create a new revision with that template. You can very well use this command to see the template of a particular revision. You can see in revision 2, the image is 1.20.1 and in revision 1, the image is 1.20.0. Now the deployment is successfully rolled back. You can see a new revision, that is number 3, is created. But the template, it should have taken it from revision number 1. Yeah, that's right. Step number 7, we will pass the rollouts and make some changes to the pod template and see if it creates a new rollout. Technically, it should not create. For this step, we will directly update the pod template using kubectl commands instead of updating it in the manifest file. Now I am executing a command to pass the rollout. This kubectl set image command will set the container image to 1.20.2. Now check the rollout history. Here you can see there is no new rollouts that is triggered. This is because our deployment rollouts are in pass state. Step number 8, you will resume the deployment rollouts now. This will immediately trigger the new rollout as the pod template is already changed in the last step. Now you can see revision 4 is triggered. This will also do the rolling upgrade since it is the default upgrade strategy. In revision 4, the container image is changed to 1.20.2. Yeah, you can see the same. Here you can see the same rolling upgrade strategy is carried out. Finally, revision 4 is rolled out successfully. Well, that's it for this lecture. This is the summary that we have discussed so far in this video. Thank you from VSPARKZ and thank you for watching this video.